I'm going to keep this right here. And now let's talk about the big dog of this lecture, and that is oh, you can't see the big dog. There we go. And that is quantifiers. Oh, quantifiers are nice. So here's the idea behind quantifiers. We've been talking this whole time about we want to be able to take something like x is even, for example, right? And we want to be able to turn it into a statement. Because once we turn it into a statement, we can use all of our logic stuff on it, right? But the problem is p of x, x is even, not a statement. One way to make it even, so I'll say, let's go green. Who knows why? For the health of the planet, Daniel. So one way to make p into a statement is to plug in a value. Right? So, example, p of 4 is equivalent to 4 is even, which is true, right? That's just the whole thing about predicates. You plug it in and get a value. So we could do that, but we haven't really gained anything, right? This just feels like an extra step of saying 4 is even. P of 4 just feels like a more complicated way of saying 4 is even. But here's the key. There's another way to make p into a statement, and that is another way to make p into a statement is to say p is true for a range of values. Now this is a little interesting. So an example of this would be the statement for all, let's say, for all x multiples of 4, p of x is true. Is this a statement? Wait, they say for all x multiples of 4, we have p of x. This guy's statement, is it true or false? Does it have a truth value? Who thinks yes? It's a statement. Who thinks no? It's not quite a statement yet?
Yeah, it's a statement.
It's a statement, right? It's either true or false that all multiples of x will satisfy p of x. Or if x is multiple of 4, p of x, x is even, will be true. In this case, this whole statement is true. It is true that every multiple of 4 will be a will be even, right? It's only a statement. Yeah. Or you could say, there exists an x prime number such that p of x. Does it have a truth value? It doesn't matter if it's true or false. Just the question is, does the statement make sense? You know what I mean?
Yeah, it makes sense.
Yeah, it makes sense, right? This is a statement. So notice, this is actually really interesting. Let me stop. this, the point is that I got too excited to start going in a circle. The point is that right now we're just saying something. We just plug something in. We're just saying something about one number. Here we're saying something about all numbers, or we're saying that for all prime numbers there's at least one. This is new. This is interesting. And what we're trying to do, and if we're trying to get to the point of saying if x is even, then x plus 1 is even. If we're trying to get to the point of being able to make that statement and fold it into our logic, well, this is really saying that for any x, if x is even, x plus 1 is even. So you see how making stuff true about a range of values is really powerful. That's going to come up later. But anyway, for now, so the reason we call these quantifiers is because we kind of quantify on what ranges p of x is true. So here, what this statement is saying is that we're quantifying that on all for the entire range of multiples of 4, p of x will be true. Here we're quantifying it, saying just for one, at least one of the prime numbers is true. So that's kind of the difference. And so this brings us to our two main quantifiers.